In this class, we are going to talk about local attraction, which is very important in measurements of directions. In measurement of direction, we use a freely suspended magnetic needle in order to get the north and south pole. So when this magnetic needle is attracted to steel structures or electrical cables, when we set up our instrument station very nearby to this construction or the existing man-made structures, then the magnetic needle, due to its polarity, it will deviate from its north. So this deflection from its magnetic north due to the effect of magnet is called local attraction. And the presence of local attraction can be found by calculating the difference between force bearing and back bearing, which shall be 180 degrees. If the error is there, then error is distributed equally among the internal angles. The local attraction can be found or can be corrected by two methods. One is by calculating the interior angles, then by applying the forebearing and back bearing, which is 180 degrees. In included angles, we will calculate the interior angles of the closed traverse. Then we apply the check for correction, that is 2n-4 into 90 degrees. And if it is not applying the check, then the error, whatever we are getting, we will distribute equally to the interior angles. And using the same equations which is used to calculate the interior angles, we'll substitute the corrected interior angles and we'll calculate the force bearing and back bearing. Before doing that, we'll find out the survey lines which are not affected by this local attraction, where the angle of differences shall be 180 degrees. Now let us take one problem. We'll solve this problem with method 1, that is, we'll calculate the interior angles, and then if there is any error, we'll distribute equally and then we'll start to correct the bearings of the traverse. See, the following bearings were observed while traversing with a compass. Line PQ, QR, RS, SV is given. Their forebearings and back bearings are given. Mention which station was affected by local attraction and determine the corrected bearings. In order to solve this problem, it is very important to plot the survey plot. Let us take survey line PQ. From P to Q, the forebearing is 124 degrees 30 minutes. Draw a line from P of approximate distance such that our angle 124 degrees 30 minutes. Let us mark the end point at Q. From Q to R plus the given data, it is 68 degrees 15 minutes. Draw a line QR of approximate distance such that it makes an angle of 68 degrees 15 minutes whole circle bearing. Now let us mark that end point as R. From R, draw a line such that the whole circle bearing is 310 degrees 30 minutes. And from P, draw a line which makes an angle of 17 degrees 45 minutes, which is back bearing of SP. With these two lines, you can mark point S. It is always to be remembered that the traverse station or the closed traverse should always be closed by drawing the two lines from the adjacent survey station points. When the traverse plot is done, now you have to calculate the interior angles. We'll look station by station. Now let us take station P. Angle P can be calculated by deducting forebearing of PQ minus back bearing of SP. Angle Q can be calculated as back bearing of PQ is deducted from 360 degrees and forebearing of QR can be added. Angle R can be calculated as forebearing of RS minus back bearing of QR. Angle S can be calculated as forebearing of SP minus back bearing of RS. Angle P can be calculated as 106 degrees 45 minutes, angle Q as 123 degrees 45 minutes, angle R as 64 degrees 30 minutes, angle S as 65 degrees. We have discussed in the previous class how to calculate the interior angles. Draw a tabular form with the table column titles as line, forebearing, back bearing, correction, corrected forebearing, corrected back bearing, and remarks. Copy down the given data in the first three columns, that is line, forebearing, and back bearing. Observe the given forebearings and back bearings. There may be survey lines where the forebearing and back bearing difference is exactly 180 degrees. If you closely observe the given data, PQ is a survey line where the forebearing and back bearing difference is 180 degrees. 124 degrees 30 minutes plus 180 degrees will give you 304 degrees 30 minutes. Which means that in the line PQ, both the survey stations are not affected by local attraction. So station P and station Q readings are all correct. So in this survey line QR, as we have stated that station Q is not affected from local attraction, we'll state that forebearing of QR 68 degrees 15 minutes is correct because it is taken from station Q. If forebearing of QR is 68 degrees 15 minutes, then the back bearing shall be of 248 degrees 15 minutes. If we closely look, I have written the calculations in correction column into relevant QR row. As because the back bearing is 246 degrees 0 minutes, there is an error in the station R. The value of error is given by actual back bearing 248 degrees 15 minutes minus observed back bearing 246 degrees 0 minutes. This gives a value of 2 degrees 15 minutes. The correction here is positive. So we'll add 2 degrees 15 minutes to 246 degrees 0 minutes and we'll write down in the corrected back bearing. Next we will go to the survey line RS. Forebearing 310 degrees 30 minutes in RS means that this bearing is observed from station R. We have stated in the previous row that R station is having a correction of 2 degrees 15 minutes. So we'll add 2 degrees 15 minutes to station R to get the corrected foot bearing as 312 degrees 15 minutes. Considering 312 degrees 45 minutes as corrected foot bearing, considering 312 degrees 45 minutes as corrected foot bearing, if we deduct 190 degrees, we will get the corrected back bearing, that is 130 degrees 45 minutes. If 132 degrees 45 minutes is the corrected back bearing but observed bearing is 135 degrees 15 minutes, we have a correction of minus 2 degrees 30 minutes. So station S is affected by local attraction of minus 2 degrees 30 minutes. We will write down the corrected back bearing of 130 degrees 45 minutes in the corrected back bearing column against RS. When it comes to line SP foot bearing is given as 200 degrees 15 minutes. As S station is affected by minus 2 degrees 30 minutes, we will correct the 200 degrees 15 minutes by minus 2 degrees 30 minutes. That is 200 degrees 15 minutes minus 2 degrees 30 minutes will give you 197 degrees 45 minutes. 197 degrees 45 minutes minus 180 degrees will give you the back bearing of SP. When you do this, you will getting 17 degrees 45 minutes, which is the back bearing. So in the entire calculations we have found the bearings which are observed from R and the bearings which are observed from S are affected by local attraction. And the station R, and we will write down the same findings in the remarks column. Station R and station S are affected by local attraction by plus 2 degrees 15 minutes and minus 2 degrees 30 minutes respectively, which is our answer.